Here's a third example in Lesson 6.4 where we're asked to determine the nature of the roots, and the answer to that question will either be there are two real solutions, that happens when the discriminant is positive, one real solution, that happens when the discriminant is 0, and we'll explain why in a moment, or two complex solutions or non-real solutions, that happens when the discriminant is negative, like we saw in example 2. So in this case, we see we have a quadratic equation. It is in standard form. A is 9, B is negative 12, and C is 4. So the first thing we want to do, of course, is determine the value of the discriminant. So that would be B squared minus 4 times A times C. And we see that that turns out to be equal to 0. So if we, first we want to notice that, okay, our discriminant is 0. That discriminant sits underneath the radical, and there is only one number equal to the square root of 0, and that is the number 0. So this is a situation where we would say that there is only one real solution. If we want to find that real solution, we would continue on with the quadratic formula. Opposite of b would be positive 12, plus or minus the square root of 0, of course we've already said is 0, all over 2 times a would be 2 times 9 in this case. So 12 plus 0 is 12, and 12 minus 0 is 12. So we end up with 12 over 18 as our one solution, which can be reduced to 2/3. So that is the third situation that could exist when you're using the quadratic formula to solve a quadratic equation. So if the discriminant, b squared minus 4ac, is equal to a positive number, because every positive number has two real square roots, then there are two real solutions. If the discriminant is equal to 0, because there is only one square root of 0, then there is one real solution. And if the discriminant comes out equal to a negative number, there is not any real square root of a negative number, but rather imaginary or complex. So we'll have two complex solutions.